Ever wondered how architects design buildings, or how GPS systems accurately track your location? These real-life applications, and countless others, owe their existence to a mathematical principle you may recall from your school days: the Pythagorean theorem. Take a moment to imagine a right-angled triangle. Picture it in your mind. It's a simple shape, isn't it? Now, this humble figure holds within it a secret that has been known to mathematicians for over 2,000 years. This secret is the Pythagorean theorem. The theorem takes its name from the ancient Greek mathematician Pythagoras, who is widely credited with its discovery. It's a fundamental principle in geometry, especially when dealing with right-angled triangles. But what exactly does this theorem say? In the simplest terms, the Pythagorean theorem tells us that in a right-angled triangle, the square of the length of the longest side, which we call the hypotenuse, is equal to the sum of the squares of the lengths of the other two sides. If we were to express this in a formula, it would look something like this: a squared plus b squared equals c squared. Here, c represents the length of the hypotenuse, while a and b represent the lengths of the other two sides. Think of it this way: if you were to create a square with each side of the triangle and calculate the area of each square, the area of the square created by the hypotenuse would be equal to the combined areas of the squares created by the other two sides. Now, let's recap the key points of the Pythagorean theorem. Firstly, it applies only to right-angled triangles. This is a triangle that has one angle of exactly 90 degrees. Secondly, it states that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. And finally, it provides a method to calculate the length of one side of a right-angled triangle if the lengths of the other two sides are known. The Pythagorean theorem might seem like an abstract concept, but its practical applications are all around us. It's used in various fields, from architecture and construction, where it helps to ensure buildings are structurally sound, to navigation and GPS technology, where it allows devices to calculate distances between points accurately. So the next time you use a GPS to find your way, or marvel at a beautifully designed building, remember the humble right-angled triangle and the ancient theorem that helps make it all possible. It's amazing how something so simple can have such profound implications, isn't it? That's the magic of mathematics, and the enduring legacy of Pythagoras' theorem. A simple principle, rooted in the geometry of a basic shape, with the power to explain and shape the world around us.